All right, let's start with short answer section, number 12. In 2002, the temperature on the first day of summer was 86 degrees. This refers to that 86 degrees. This is 6 degrees less than it was on the first day of summer the previous year, 2001. The question is, what was the temperature on the first day of summer in 2001? Now, your tendency is to think, well, the temperature was 86 plus 6. Well, that's what you do to solve it. But when you're translating from English, from words, to a math problem, to an equation, you need to translate accurately. So to translate this, we would say 86 is or equal to 6 degrees less than 2001 temperature. So this is how we would write it. 86 is equal to the temperature from the previous year minus 6. 6 degrees less than the temperature it was last year. So we would write it this way. Once we set up our equation, we solve for t. We add 6 to both sides, and we end up with our 92 degrees. And then just go back and check for common sense. Okay, so this 86 degrees in 2002 is less than 2001. So 2001's temperatures better be more than that. So make sure you use common sense. All right, number 13. The range of a set of scores is 27. And I gave you the hint that a range is the difference between the highest and the lowest values. And I just have R being the number that we're looking for. It says the lowest score is 39. Write and solve an equation to find the highest score. So R is going to be our highest score. So we know that the range is the highest score minus or subtract the lowest score. And that should equal our range of 27. So we plug in the numbers that we know, and that's our equation. R, or H for highest score, whatever letter you want to use, minus 39 equals the range of 27. So we're going to solve the equation, add 39 to both sides to get our 66. And then go back and check it just to make sure that this is accurate. 66 minus 39 should equal 27. All right, number 14. This is just a plain solve the equation. How do we undo the plus 6? We want to isolate our g. So how do we undo plus 6? We use the inverse or opposite operation. So we're going to subtract 6 on both sides. Now I want you to write it out on this side. Negative 18 minus 6. Now go back to what we learned about integers. We're going to keep, change, change. So we're going to rewrite the question. Negative 18 plus a negative 6. When we're adding same signs, we add them and give it the same sign as the two numbers we're adding. So it's a negative 24. Go back and check it, plug it in, make sure negative 24 plus 6 equals a negative 18. All right, number 15, we're going to solve for S. We're multiplying, so to undo multiplication, we're going to divide by what we're multiplying here. So we want to undo multiply by 12. So we divide by 12 on both sides to keep it balanced. So 36 divided by 12 is 3. Go back and check. Takes you 2 seconds to check. 12 times 3 is 36. All right, starting on the next page, number 16. All right, I want to solve for Q divided by 9 equals 30. So I have division going on here, so to undo division, I'm going to have to multiply. So I'm going to multiply by 9 because I'm getting rid of divided by 9. Multiply by 9, but do it on both sides to keep it balanced. There's that equal sign, means they're balanced. So 30 times 9 is 270, and then go back and check. 270 divided by 9 equals 30. All right, number 17. A city manager wants to reduce morning traffic by increasing the number of buses and reducing the number of automobiles with single occupants on the road. We're just trying to get less cars on the road. So they want to eliminate 924 cars with single drivers each morning, and they want to use buses. Only one bus can transport 28 people, so they need to know how many more buses will the city need each day. So to set up my equation, I'm saying 28 per bus times the number of buses equals the 924 cars they're trying to get off the road. So to undo the multiply, I divide both sides by 28, and I get 33 buses they're going to need to get rid of the 924 cars. All right, For number 18 and 19, these are two-step equations. And as we noted before, and I want to make sure you understand, this is the big note right here. When you have two-step equations, you undo any adding or subtracting first, then undo your multiplying and dividing second. So this is a two-step. Undo the adding and subtracting first, then undo multiply and divide. So 18, the first thing I'm going to do is undo the plus 4. So I'm going to subtract 4 on both sides, and then I'm going to rewrite 9n equals now 36. Then I'm going to undo the multiplying by divide by 9, both sides. 36 divided by 9 is 4. Go back and plug it in and check. 9 times 4 is 36, plus 4 is 40, and that equals 40. So you're good. All right, number 19. Two steps again. So I want to undo this plus 5, the first thing I do. So I'm going to undo it by subtracting 5 from both sides. And then I'm going to rewrite. Z over 9 equals 5. Then I'm going to get rid of the divided by 9 by multiplying by 9. 5 times 9 is 45. Go back and check. 45 divided by 9 is 5. 5 plus 5 equals 10. I'm good. Make sure you check your answer. It doesn't take very long, and you just want to be sure of your answer. Use your common sense. All right, number 20. This is one of those riddles where you have to solve one to get to the other. And I'm hoping that you're getting to a point where you see something like this equation, 4x equals 28, that you automatically think x must be 7. It has to be, if 4x is equal to 28. So if x equals 7, I can plug that in to this expression. That's 5 times 7, so that'll be 35. So now it's 29 minus 35. That equals a negative 6. You could rewrite, doing keep, change, change. It'd be 29 plus a negative 35. Still equal a negative 6.